Hey, what's up guys? So welcome back to today's video. Let's take a look at how we can make any UI object follow any 3D object in your scene. For instance, this is a UI object, which is this small square here. So this square is a UI object, and then I currently have it follow this one around this ball. And as you can see, if I were to move my camera, it just going to stick with the actual object that I have set it to. I can move it there and here, and it's just going to stick with it. I can move forward or even backwards if I wanted to. And yeah, and I even have some more controls here. So for instance, I can even allow the UI object to move off screen if I really wanted to. And now I cannot actually see it because it just sticks to the object. Or if I always want it to appear, I can also just do that as well. And I can also add offsets and so on. For instance, here I can add an offset if I really wanted to. So it's actually very simple. So let's get into it. So now let's take a look at the actual code. So this is the UI follow object. And as you can see here, we've got a singleton pattern that we can use to call any methods in here. Obviously that you can change. You can, for instance, have it on a per object basis. And in this case, then you will not be using this. But apart from that, we've got a transform, which indicates what object to actually follow, and then the object renderer itself. The reason why I want to use the renderer is so that I can access the height and width of the actual object. As you can see here, we'll take a look at that in a bit. And then we've got the actual UI object and an offset, which is a vector free, and a reference to our camera and then our flag. On a wake, it's very simple. We just initialize the instance and then just get the main camera. Obviously, you could eliminate line 17. If let's say you have multiple cameras in your game, then you can just assign one here and then just eliminate the 17th line. That's totally up to you. And on void fix update, this is where the actual logic comes in. So first we check whether or not we have an object to follow. So if object to follow not equals to default, and the renderer as well does not equal to default, then we can execute the code. Else we'll just disable the actual UI object because there's nothing to follow. And then here we just enable it, and we calculate the screen position of the object to follow. All right, so this is very simple. We just take the camera and then we just call the method worldtoscreenpoint. This basically takes in a world position and then just returns a screen position. So this allows us to get the current pixels in the screen space that would actually be on top of that world space position, if that makes sense. And here we need to get the rect transform of the object to follow renderer. Okay, so we get the rect, and then we pass on the camera as well. And then we can just calculate the new position. This is very simple. So here you can see that position equals to screen position plus offset. And then here we create a new vector free where we take the width of the UI object, we divide it by 2, and then the same thing for the height. The reason that I add this last piece here is because if you were to eliminate that, then the UI object would be positioned based on its middle, its center. Obviously, that might not be an issue for you if you've resized the center, if you've modified the center. But for most use cases, the center would be the actual center of the object. So if you do not actually do that, then you'd see that your UI object can actually will not be placed well. So this basically just ensures that we are anchoring one point or one corner of the object rather than the middle. And then here we just call allow position override. We'll take a look at this in a bit. And yeah, this also returns a vector free. And then here we just basically do UI object.position, and then we just override the position. So that's basically it for the actual following script. And obviously you could have it on void update or any other method that you prefer. The fix update here is just for testing today, obviously. If you've got, let's say, a lot of objects that you need to follow, fix update might not be suitable for you, but that's something that you can explore on your own. And now here we've got the two remaining methods. So the first method is allow position override. So what essentially this does is it takes in the position that we currently calculated, and then we just check whether or not it is off screen. So this is what it does. Okay, so if allow object to move off screen is true, then we just return the current position. But if it's false, then we want to check whether or not the position of the UI object is inside the screen area or it's outside. If it is outside, then we just want to return whichever position is inside, but closest to that new position. So here we just have two boolean, is outside X and is outside Y. The reason why I've put it into two separate lines is because here I want to modify the X individually and the Y individually. So this way, let's say horizontally the object is outside the screen, but the player moves up, the UI object can still move in the vertical position. And it's very simple here. We just take the position.x, we add it to the UI object of the size of the UI object, and then we just divide it by 2. Same thing for the height, and then we just compare it with the screen.width. Either that, or we do the same thing, but now we remove or we deduct the actual half size, and then we check whether or not it is lower than 0. So this is basically the two edges of the screen, both up and down. And now we get the new position. Again, here we just check whether or not it is outside X. If it is outside X, then we just return the current position of the UI object. And if it's not outside X, then we can return whichever position we passed in. And the reason why I use the UI object at position.x instead of some other values is because this gets called before we assign the actual UI object to the before we assign the new position to the UI object. So in all cases, the UI object will be inside of the screen area. And if you, let's say you wanted just to make sure that this never breaks, you could have another vector free called last position and then use this here. Finally, the get screen rect just tries to get the bounds of the renderer object by using renderer.bounds. And then here we can just build a vector free, alright, to get the corners of the actual mesh of the actual object. And then we just try and take it from a 3D space to the screen position. And then we just return the rect based on these calculated values. So as you can see, it's quite simple. It's just a bit lengthy. Here we have a vector free array for each corners of the mesh. And then we just access bounds.min, bounds.max on each axis. And this will just give us a square on the screen, which would actually tell you where exactly the object is appearing on the screen. And here we just find the minimum for the X, maximum for the X, and min for the Y, and maximum for the Y. And then we just return that. So that's about it for the actual script setup. So if you guys found this video helpful, please be sure to leave a like, subscribe if not already. And if you've got any queries, questions, or anything that you wanted to add or clarify, please feel free to let me know, guys, in the comment section down below. And yeah, so I hope you guys enjoyed this video. And yeah, so I'll see you guys in the next one. Bye.